Welcome again, everyone. It's great to see everyone back for this special silent experiment share. So you can see I'm talking right now, so the whole thing won't be in silence, but the experiments will hopefully be shared without talking. It's going to take a bit of patience, and it's pretty difficult to plan this. I know from planning my own experiments. So everyone watching, please be patient if things don't work out exactly as they planned. Please, like usual, feel free to ask questions most of the time, but bear in mind that some of the people presenting this time might be less comfortable or confident in English as some of the times when everyone's speaking. So be extra patient or aware of that if you try and ask things. Sometimes if it's easier for some people, feel free to prefer using the chat. Usually I say like avoid the chat and speak to us as often as possible. But if you prefer the chat so that things can be copy pasted to in translator, feel free to use that if that helps out as well. As I mentioned in the email I sent out, if it's useful for any of you, I also speak Spanish, French, Italian, and kind of understand if you speak to me in a Latin language, I'll get like half of it if you get stuck on something. So like feel free to try things out if you're struggling with the language. I think that's enough talking because things are supposed to be silent. So we'll turn things over to our first experiment with Nasko joining us from Bulgaria. For one that I'm very much looking forward to. When he mentioned it, he said it's going to involve something with fencing. So Nasko, really excited to see this one from you. Turning things over.
Just a little bit of talking. Hello, everybody. You can ask me some questions later, but now let's go on to the experiment. And that's it.
Beautiful. Thank you. Does anyone have any questions or feedback for Nasko?
All right.
Is it something you do in your classroom, Nasko?
Well, I'm a chemistry teacher, but today I'm a fencing training. So I thought of experiment that I can do while I'm on my training. I do a little bit of physics from time to time, but it's not my main experimentation.
It's brilliant.
Yeah, really a great way to bring in other things. I always love it when I see teachers bring in something that they do outside of school and make it like make their subject interesting for kids that way. Like me personally, whenever I can bring in a bike or use a bike as an example, because I've traveled a lot by bike, then I'll try and use that as well. So I really love to see those examples of balance and center of mass.
Well, yeah, it was really, and I really enjoy the way you can almost drop my phone here. I really enjoy the way to find the center of mass, and of this sort of obscure object is really, really prominent when you're moving one finger and you say, "Oh, all right, I'll go to the guard, it's fine," and then the other finger starts moving. It's always really interesting for me, that one.
Beautiful demonstration.
Yeah.
Thank you. Well, do you have any other questions? Because unfortunately, I will not be able to continue being present here, because I need to go on and get hit with a blade. So I'll watch you all on the recording, and I'm looking up for that. So we are getting back to Michael, I guess, and have a pleasant time.
That sounds great. Thank you again, and don't get hurt in fencing. And so the next one up, we'll be going all the way to Spain to see.
Sorry.
Oh yeah,
Michael,
yeah.
Can I just, because I'm in the lab, everything.
Oh yeah.
I have things here around. I have here one thing just to show. Can I?
Oh,
with
perfect.
No
Yeah. That's great. I'll get rid of my spotlight so people can see you better. Just a sec.
That's it. I have more things, but they are in the basement of the school, so I could not bring. I didn't know what he was showing, but I always have this one here. And we can also put in the table, and you can make a magic about it.
That's beautiful. I saw Marisa applauding, and I've seen similar things in her lab in Spain. So that's also a great transition from Bulgaria to Portugal and now over to Spain. So thank you again for sharing that. So I'll get rid of your spotlight. Okay, so about to turn things over to Marisa in Spain. And so Marisa is a really great teacher, and I'm really glad to finally include her on one of these experiment shares. I've been trying to get her on for many months now, and every month we say, okay, maybe next month, maybe next month. So finally now we have Marisa here. She's a little bit shy in English, and she was one of a couple of teachers I was thinking of when I first came up with the idea of the science experiment shares. So it's great to finally have her on to be able to present something. With no further ado, turning things over to Marisa in Malaga. Marisa, parece que tú hablas en esta parte, pero tu micrófono está apagado. Entonces, si quieres entender, necesita pegar el
Michael,
micrófono.
no puedo usar colorante porque me tengo que apoyar para pasar de uno a otro.
Es solamente de pasar de un experimento al otro. No he entendido.
Sí,
Perdona, interrumpí.
Ok. Con colorante.
Perdón.
Ok. No puedo. Ok, no.
No, pero es visto que tus labios se mueven. ¿Quiero hablar?
Habla español, I will translate. Okay. Portuguesa.
Thank you. Se hace lo mismo con colorante.
Okay, faz o mesmo com corante. Oh, sorry. You make the same with color. Yes.
Y pasas con la pajita de uno.
Okay, and we pass from one to another one, to the other one.
Y se encapsula sustancias.
Okay, so you can see the two substances, they go together, but because she cannot pick up both at the same time in the camera, probably I think it's the problem. That's why she could not show that.
Okay, thank you.
And it's okay. All the different things you can encapsulate, and it's worth mentioning that just recently, Marisa authored or co-authored with David Faintenby an article on this exact same experiment, and we'll either add the link to the chat, or I'll email it out later with the recording of the session if we don't get it in time to add it to the chat. And I know from experience it's a really cool experiment, and she's coached me through trying it out and actually doing it myself. So it's definitely worth checking out and trying out. It's been really great to have you share that, Marisa. Does anyone have any questions or feedback for her?
Any question?
I do have a question, but I'm afraid my Spanish is too bad, so I will need somebody to translate.
Yes.
But between Rute and I, we can translate, no problem.
Fantastic.
I can translate from Spanish to English. The opposite, I don't speak Spanish, but I understand.
No,
Okay.
I speak Spanish well enough. Ask the question, I'll get it into Spanish for Marisa.
In which process is this experiment relevant? So in everyday life, when would you use this experiment to link it with everyday life understanding of our students?
¿En qué proceso es utilizado? Como en la vida cotidiana, todos los días, ¿cómo puedo usar en la vida de los alumnos?
En el estudio de los tensoactivos, de los jabones, cómo destruye con el coronavirus, el jabón ha tenido un impacto. Y en la capsulación, nosotros lo hemos comparado con la capsulación del ARN mensajero en la vacuna, ya que en las cadenas hidrófilas e hidrófobas es como se disponen las estructuras de los liposomas en la membrana, en la antiburbuja.
Okay, I think I got the gist. Okay.
¿No?
And the audio, for me at least, it was cutting in and out as well. The audio.
So I could understand that using COVID and talk about I don't know the name in English.
Encapsulations, yes.
So
yeah.
she will explain
the envelope,
yes, envelope. So hydrophobic and hydrophobic. So she used this to then explain that.
Okay.
Okay, brilliant, thanks.
Es como en la comparación, ¿no? En la nanoencapsulación, en la nanotecnología de la encapsulación de la ARN.
It's
Okay,
like, yeah.
gracias.
And are there any other questions or thoughts on Marisa's anti-bubbles or no bubbles?
Bubbles. No bubbles. En composición es todo lo contrario. Anti-bubble.
Everything the opposite. Yeah.
Okay. Excellent. Thank you again, Marisa. And,
thank you.
And so now the next up, we're going to go all the way to Croatia for Slavica. And I've the video queued up. I forget, I asked you right before we started if I was going to introduce you first, but since you're there, I'll introduce you before playing the video. Did you want to say anything before I start your video?
No tiene...
and you're mute.
My name is Slavica Bernatović. I'm a physics teacher. I work at technical school in Slavonski Brod in Croatia. That's 200 kilometers from Zagreb, east from Zagreb.
Excellent, thank you. It's great to have you sharing. And with that brief introduction, that gave me time to get the video ready to go. As sometimes I have problems with this, please let me know if you don't see a video queued up, and if when I start it, you don't hear the, oh no, there is no audio because it's silent. Never mind, that saves one thing I often mess up. So here we go.
There's nothing. No.
No, like
there's
no.
Nothing.
No, we don't.
You're not seeing the video.
The light, right?
Let's try that one more time. So it was good I gave the warning to let me know if things weren't working. Now can you see a video that should be being shared on my screen? I'm getting the thumbs up from Slavica. Okay. Let me know if it's not working. Beautiful. Does anyone have any questions or feedback for Slavica? I really like the variety of seeing a whole bunch of different things. I had one question. I was wondering, with the showing the dispersion of aerosols, and it appeared to be food coloring in hot versus cold water. The spreading was a lot quicker in the hot water. We saw it from above. Was the spreading throughout, or was it on the surface mainly? Like, was it being carried by a movement in the water, or was it just the thermal effect?
Turbulent effect throughout all water, all volume.
Oh, they were both
not
the same
only surface, not only at the surface, to all fluid water, through all volume, spread colored fluid spread through all water.
Oh, okay.
Is that question on the surface or to volume in space, all space?
Yeah. No, I was really interested because the experiment I'm going to show later includes a similar effect. So I was really curious about where it's similar and where it's different, because mine, it's a flat layer of water, and we see it mainly in like 2 dimensions rather than 3. So that's really interesting to know that it is going in 3 and not just on the surface. So maybe I'll come back to that after I've shown my experiment. Does anyone else have anything they want to ask or share?
No, I have to say that this was one of the experiments that I had. It's not the one I'm going to do today. It's a volcano in the water, the convection current. So I don't know if it's the same, but it's nice to know that we would choose probably similar experiments. Really nice.
Okay, nice. Mm-hmm. Okay, nice.
So science is universal. And any final things for Slavica before we move on? Okay, and thank you again. And then the next on the order is Liliana from Albania. I didn't get a confirmation that you are presenting, but I see you're here. Please let me know if you have something that you do want to present. And no answer, so we'll get back to you. If you do have something ready, just jump in and let me know. The next one on the order is Gina in Romania, and I don't see her in the Zoom. So again, we'll come back to her later if she ends up being in here. Or if Gina, you're here and you're under a different name, just let me know, and I'll be happy to have you jump in. Doesn't sound like it. Okay, so moving on in the order, we have Gordana Varnica from Serbia, and she's another one who she sent me a video because she was unable to be here, but she still wanted to share an experiment. And I'm realizing I was hoping to queue it up while someone else was sharing an experiment, so I don't have it queued up. Is anyone else able to jump in with their experiment? Because mine's the next one on the order. If not, then I'll. Hey, it looks like Paul here. Excellent. I had you way down on the order because I knew you might be late coming from a meeting. Are you able to jump in so that I can have time to cue Gordana's video?
Yeah.
Excellent. So it's great to have you back again. Everyone probably knows Paul already. No more introduction necessary. Great to see you again, Paul. Thanks again.
Yeah. If I can take the pressure off you in any way, I will try. I'm actually going to mute and change my camera, and I'm gonna try and keep quiet, which is always difficult.
It's tough. It's tough, but I know you're up for a challenge.
So that's me finished.
Paul, you nailed it, this experiment.
Thank you. Love the pun. I hammered it.
I'm just trying to come up with another pun, but I loved it.
I don't know, could you pin or spotlight there? Did people see? But there's about 26 nails or so on top of one. And you could go more.
That sounds like a challenge. Sometime when I find some time, you'll get a video or a photo from me with at least 27. Did you say 26 is on? With at least one more than you showed today.
Okay. The real challenge, if you want to challenge, is to do 3 or 4 to go the opposite way.
Oh. Because the more you have, the easier it is to balance.
Well, because you've got a structure, and this top one on each landing is the brace, which keeps everything in place. So if you've only got 3 nails, it's really difficult to have the brace acting.
As usual with you, lots of things to try out and keep me busy afterwards. Does anyone else have any thoughts or questions for Paul?
I think it's a great one. I like it.
So thank you again, Paul. And that gave me just enough time to queue up Gordana's videos. So while I'm trying to make sure I get the screen share working right, and please let me know if you see anything other than what appears to be a video. So there's two videos that Gordana shared of different experiments. This is one demonstrating how the shape of the Earth is affected by rotation.
Very poopy.
And then the second one on Lenz's law, let's make it full screen again. Let me know if this doesn't seem to be working out right. And here we go.
Czekaj, nemoj još sad, czekaj. Dobar, pokazuj. Odlično. Sad pokaži drugi. Sad napiši.
And so we saw the time difference from it following with Lenz's law. An interesting thing to note with those experiments and a lot of what you see in Gordana's lab, a lot of it, including those two, she's put together herself out of materials that she found there. And I'm actually going to be in Gordana's lab in Požega, Serbia for her school's gym festival. In there and in a lot of Eastern Europe, the high schools are called gymnasium. And so they've invited me to see that. And because her science club is one of the most regular participants of my Yes International meetings, which are like a student version of these experiment shares, I'll be there in 2 weeks. And one reason why I'm mentioning this is because I'll send out an invitation to everyone who clicked the little box when you signed up for this experiment share or any other saying you want to be emailed about other things going on. And there's going to be a Yes International meeting where it'll highlight some of the projects that her students have prepared to share with people really from all over Serbia and a couple of international guests like me. So I'll organize a short Zoom sometime on Sunday, the 22nd of May. I don't have any other details yet as to like what time or what experiments they'll be sharing, but if anyone's interested in that, check your inbox for something on that, because there's going to be exciting things coming from Gordana's students in Serbia 2 weeks from yesterday. And because she's not able to be here in person, we won't bother asking if there's any questions for her because she wouldn't be able to answer even if she was. And we're getting near the end of the order. Unless I've missed someone, and jump in if you believe I've missed you, there should be a Rute left to go in Portugal. Astrinos informed me there's a power outage in his part of Crete, so he may or may not. Oh, he is there. Okay, and there's me still to go yet. I have no preference of the end of the order, whether you guys want a minute still and I'll go, or if anyone wants to go before me. Rute, Astrinos, any preferences? So I'll say let's. Oh, Astrinos, any preference?
I'd rather be the last one.
You'll be the last one. Okay, perfect. So I'll jump in and go because I have my assistant ready to film the experiments with my second camera, which I'll spotlight now. So I'll turn that on and then I'll stop talking and hopefully I'll be able to explain it visually enough that you'll know what's going on here. Okay, spotlighting the second camera. And that's that one. Any questions or thoughts for me?
Is that Wien's law? Is that Wien's law?
Yeah, well, yes, and you can derive it.
Different colors, different wavelengths, different energy, different colors.
Oh, so
do you understand?
No, I don't.
Transfer of energy. Transfer of energy. No.
I don't think I understood the question initially. So
is that for Wien's law? Wien's law.
I'm sorry. I should be familiar with Wien's law, but I'm not.
Yes, Wien's law is when you have a body that is hot. It's like the stars. You have red stars, white stars, yellow stars, and the white blue. So it depends. So the temperature, and you will have different colors. I think it's what you are talking about, isn't it?
Yes.
Ask the question.
I think that is.
Oh.
That is also. I don't know. You can for anything else. For what? For what else? Tell us.
I believe it's different.
So at least as far as I understood what I was trying to show, it didn't involve that at all. But I would think you could use it to help model that, like with some creativity. But for me, what it was showing was diffusion. And I was first shown this experiment by a teacher from Israel who was on the national exam board. And there they have a really interesting problem where they want practical exams, like a practical exam component of the national exam, but they want it to cost no more than the equivalent of about €1 to €5 per student, so that all the schools in the country can do it, regardless of whether they're in a wealthy district or poor district. And so he came up with this experiment to measure the rate of diffusion. So that was something I considered doing, but trying to explain it without talking as well, taking it, making a graph to graph the rate of diffusion over time at different temperatures was one step a little too ambitious. But with the colors diffusing out from the M&Ms and not mixing with each other, I found that always surprising. And for most students, that surprises them that colors don't mix. And it wasn't intuitively obvious to me when I first saw the effect. And it only took, after a lot of thinking, I realized, okay, of course they're diffusing at the same rate and they're not mixing, because the sugar is a much smaller molecule and will diffuse a lot quicker than the dyes, which in most cases, organic dyes tend to be long chain molecules, which would diffuse a lot slower. There's a lot of exceptions to that. So that's not a hard and fast rule. But generally, the sugars diffusing out from the candy will carry longer molecules with them. So we'll see all the colors diffuse at approximately the same rate, but also they won't tend to mix with each other, and they'll form barriers. Like even after some time, this one, you see barriers. And if you look close, and this is a horrible shot, so you probably can't see it that close, but you do get some mixing across the barriers that's around 10 times slower than the rate at which the coloring, or the sugar, carried the coloring initially. And that was the point of adding the sugar cube afterwards. It was showing that it was a gradient of concentration of sugar that was keeping things separate. So the sugar cube appeared to repel all the other colors as well, but pushed food coloring on its own away. So yeah, that's what I was trying to show there. I don't know how well it came across or not, but that's one that, for me, has always been a fun visual experiment. Any other thoughts or feedback on that one?
I think if you're going to use it to model Wien's law, you might run into problems with the different colors and the temperatures associated with the different colors.
Well, of course, we wouldn't have water at a couple thousand Kelvin. No, I was thinking more of like, yeah, I don't know if it's a doable idea. Like something along the lines of, you could use them to represent different stuff. No. Yeah, I'm not sure the idea has any potential.
But if you have warmer water, you probably will change the diffusion rate, which is another investigation. It could be fun.
Oh yeah, yeah, and like to do that as an investigation, it's not that much harder. Like if you use a transparent dish, or a lot of labs, you have a lot of Petri dishes lying around. If you just do that above a piece of graph paper, like millimeter paper, or especially if every like 5th or 10th millimeter, you go over it with a heavier marker, because once you're looking through the dye, you might not, like you might lose track of the lines easily. But I've had students do that, and it works out reasonably well for them.
Cool.
Should we move on to Rute in Portugal before finishing with Astrinos in Greece? Is now an okay time for you, Rute? Perfect. Okay,
yes,
so
we never know who enters in the lab, but that's the good part. We never know.
But they're always welcome, and they can always learn something new.
Yes. So I don't know with the cameras, let me see if this is going to work. In the middle, I have to change the camera, okay? I hope that will be okay. So.
And if you want, I can change the spotlight, or like just let me know, and I'll do things to the best of my ability.
We'll see how it'll work. And that's it. I don't know if it was, if you understand, but I try. Any questions?
That's really beautiful. Can I check that I understood? Because
yes, yes, of course. Yes.
At first, I didn't understand the part with the chain, and then at the end, I'm pretty sure I did. But I want to check that I got it right. So
Okay.
that was showing that when the pencils are there, like I don't know what the thing was in the chain, but like the
So
thing.
it's this, it's monom, I don't know in English, sorry. I tried to write in English, monomer, I think it's the
Oh
name.
yeah, okay, monomer, yeah.
Yes, so this will represent one monomer, sorry. And then all together is the polymer, the plastic. And so I use this to show that I was looking more deep in the plastic. And so when you use the pencil, and I use this one because it was bigger.
Oh, so it was a pencil, okay.
Yeah, I have these big pencils when I want to kids to, you know, to how you call, Gabriela, to sublinhar. Underline. When I want them, and I show this in the class, so I have this one to show that we are in a smaller scale. And so when the pencil goes here, and the polymer goes, you know, around, like hug the pencil. You see, it's what I want to show. So it's a kind of elastic material, and so when you put the pencil, it will hug. I didn't put more pencils because this plastic is the one I had here. It's very thin, because normally if we use a little bit thicker one, you can put, I don't know, 15. I use it with lots of them. Yeah.
Oh, that's really great. And that makes more sense. I missed that part. So thank you for Now we need to get.
You also can use a balloon with this, like. With this, with a little bit of oil, and you can pass through the balloon without
without popping it.
Yes. Yes. Well, it has another explanations like the pressure and so on, but it's also a nice one. But because not always will I get this one, so that's why I use this one, the plastic bag with water.
Now I need to buy more chain. I already bought smaller chain after things that Paul showed me, but that size would be better for demonstrating this. So one more thing to add to my shopping list, but thank you. Does anyone else have questions? I've kind of monopolized the questioning of Rute for now. And it looks like no one else has any other questions. So Astrinos, are you ready if we switch over to you in Greece? And Astrinos holds, I think he holds the record for never having missed one of these, although I think Paul's been at everyone as well, so I'm not sure. But despite a power outage that threatened to make him not able to connect, he's with us here now, so I'm really glad that you were able to join. Looks like the power's back on, and I'm excited to see what you're going to share on rocket science.
Well, I think that is all. I was just trying to demonstrate the basic principle under the stability of a rocket. We have 2 points. Maybe I didn't do the best job, but I want to show that this is the center of gravity, and there is a center of pressure. The center of pressure is the center of gravity of the rocket's shadow, and it should be behind the center of gravity for stability. And the distance between them should be around one diameter of the rocket. Here, center of gravity of the rocket, center of gravity of the shadow. Center of gravity is actually the center of gravity of the shadow is the center of pressure of the actual rocket, and it is behind because we have the fins. The bigger the fins, we change. It goes a little bit to the bottom of the rocket, and you actually have 2 forces. One that tries to put the turns to turn the rocket downwards, and the other that actually, and of course you have more, but it depends. Here, for example, if it tries to, let's say that you have only these fins, if it goes like this, then, and it is in a stream of air, then it should go like this to be stabilized. But everything depends on this distance.
I'm still thinking about that. That's really interesting. I'm surprised I've never thought about any of that before. But when you say that the shadow of the rocket, that's just like the imprint of it, like on the ground, as if it were being illuminated from above, and what we see.
Yes, actually the projection on
plane. And so it'll be dependent on the angle of pitch of the rocket. Like it'd be shorter if the rocket's at a steeper angle, right?
Yes.
And does that law apply regardless of the shape of the rocket? Like, if rather than just having the stabilizers or the wings or at the back, if you had other smaller ones somewhere else on the rocket, the same principle would apply?
This is actually empirical. You still have to run some tests and simulations in specialized software to know that you have done everything right. Because you cannot, maybe the center of pressure is a little to the front or to the back. But after you do this, for example, you put the center of pressure on your rocket, then if you do it for your students, for example, you tie this at the center of pressure. Of course, it will not. It's not the, as you can see, it's a lot different than the center of gravity. But if you do this and then you rotate it, if at any point your piece of rope is perpendicular to the rocket, it's like this, then your rocket is stable. If it is something like this or like this, when you turn it a little bit fast, then it's not stable. It should be, if you see it from at a lower level, it should be something like this when it turns. If it's like this or anything else, your rocket is not stable. So you have found the center of pressure empirically by using the shadow, because the shadow doesn't take any account of the different masses. You only have the shape. That's why we're talking about shadow. It's the basic shape of the rocket. Without you don't care if this is wood or this is metal or anything. And so you find this, and then you turn it above your head very fast. If it's like this all the time, this is the center of pressure again, then your rocket is stable. I think that this goes too much for a silent experiment, but maybe we do it in, we are going to present it again, I guess. But this is what I wanted to present, something that I had not done before.
Well, it was good. It has a lot of visual components. So I'd say I understood 80 or 90% of it. But yeah, I think probably all of us felt frustrated at some point not talking. But that was also one of the points to this, so that we all go through feeling what it's like to have difficulty trying to express yourself. And for me, that's always been something very useful when living in France as a non-native speaker, or traveling to Spain, sharing experiments there, being in Italy, being able to feel like the awkward person who can only kind of speak the language, and being able to know what that feels like, and still be able to share experiments like that. So even though it's for the rocket one, or really for any of our experiments, there were things we could add when we could speak. For me, at least, it's a good experience practicing doing things without talking sometimes. Are there any other thoughts or questions for Astrinos?
I'd like to say, Astrinos, I always learn from you, even when you're not speaking.
Thank you, Paul.
I feel the same way, and with you too, Paul.
Yes.
And the experiments I chose, I really went for very, very simple visual that didn't need too much explanation, but we are very reliant on explaining things. It's only occasionally that we can show something and it's self-explanatory, self-evident. We need more than the visuals. Maybe it's because we're teachers. If we were magicians, we would be hiding the science. But we want to explain. We want to explain. So thank you, Astrinos. That was really interesting. And you've got me thinking about something that I've never thought of before.
And we've seen from everyone. Paul told me he's got more things to share if we're up for it. I know I certainly am. Can anyone else, if you're interested in sticking around longer to see more from Paul, either give it a thumbs up, or if it's getting late, don't worry. Okay, we've got at least one thumbs up. So I'll say there's at least two of us who are really eager to see from you. So we'll keep things open. If anyone else is getting tired and you need to go, don't worry, you've already been with us for an hour and a quarter. Don't feel bad if you have to go. Two quick announcements before I turn things over to Paul. Like I mentioned earlier, I'll be sending out an email if anyone wants to join to see experiments from Gordana's students in Serbia on Sunday the 22nd. And sometime in the next couple of weeks, I'll be launching my second annual Homemade Science Video Festival. I'll put a link in the chat of the playlist of videos last year. Coming up with the guidelines and forms and communication to launch this year's one. has been on my to-do list for a couple of weeks. Haven't gotten around to it yet, but I want to make sure I get it done before the end of the school year in France and hopefully in at least a couple other countries. So it should be out in the next couple of weeks. Check your inbox as long as you check that you want to hear from me for things like festivals and things like that. And hopefully either you'll participate with a short video or especially get your students to. It's open to both teachers and students. One of the ideas is to get away with barriers between teachers and students and encourage everyone to share experiments as roughly equals. And June's experiment share, I've got a couple of requests to try and make it on a weekend. I'll try and do that. June's very busy. I don't know which one yet. If you have requests, I'll try and try and make everyone happy, but yeah, it's not going to be perfect for everyone. That was my announcements. Without dragging things on further, I'll get back to Paul, unless anyone else has anything they want to announce before we see Paul again. Okay, so Paul, the floor is all yours.
Okay, thanks. Thanks, Michael. And indeed, for the opportunity to show this, because I think it matches in really well with what Rute was showing us as well. So it's all about the elastic properties of materials. So I'm going to switch over my camera, hopefully. And I'm going to So that was my first silent or my second silent demo. I'm not going to hold people, but anyone, any question or comment?
A short comment. I've seen similar ones with nails, but I like the portability of the thumbtack one. And one idea I'd like to try out is with the thumbtack one, because it's flexible or at least semi-flexible. I'm guessing you could bend it in such a way that you'd have a small enough number of pins you could pop it with the same bed of nails. Like I'm thinking bending it the other way around so that you'd have one or a small number of pins that come in contact with the balloon if you push it on when it's the exact same surface, just different orientation.
Yeah, I like to think that this is the poor man's bed of nails, because I do have a bed of nails in the lab and it cost a lot of money just on the amount of nails. But usually when I do this, I have one thumbtack and then pop the balloon and then show the cushion. And I usually sit on this myself. And I usually put the balloon on top and then sit on the balloon as well. And it doesn't burst. So yeah, it's the thumbtack cushion. Okay, so will we go for my last one? If there's no other question on it. Okay. Okay, I don't know how well that came over. I was battling surface tension with my Cheerios.
I noticed that, and I sort of like felt the frustration you must have been feeling. But on the other hand, I was thinking, yes, surface tension, because I love demonstrating how they'll stick to each other, the Cheerios or anything else floating like that, and they'll stick to the walls to demonstrate surface tension.
I normally use the bigger, even though I don't eat these things, because they're not nutritionally, they're not very good, but they do contain, and I don't know, could you see, 89%, 13 micrograms, I think, of iron per 100, 89% of the iron content, or the recommended iron. Okay. And the bigger ones, I should have got the bigger ones for you. The bigger ones work a lot better. Okay, but the surface tension of the water was causing these to clamp together, to stick together, and they didn't behave as nicely as the bigger ones. So I prefer that to extracting the iron out. I think that's that's quite difficult, and using the
just messy.
Yeah, and you don't get much iron. But definitely, if you're going to try this, don't use these mini ones, because the surface tension just takes over. So everything's an experiment.
Well, and one workaround, if you have to use those, or you could use things like corn flakes or like any fortified breakfast cereal, and it doesn't need to float nicely like Cheerios or other like ring cereals, is if you make a torsion pendulum by just getting a drinking straw or anything that's quite light and hanging it on a thread, and then it takes very little force to get it to spin or turn. So like I've done that as well. I don't know why I was doing it that way specifically. It might have been that I was showing with grapes as well, because you can show, I guess, diamagnetism if you have a strong enough magnet with a setup like that. So it does also work with that if you don't want to get things wet and use water, and if your cereal is just not the right shape.
Yeah, just the question there in chat. Yes, 89% iron of the recommended intake for 100 grams. There's 13 milligrams. 13 milligrams. Let me see. Can I get this without the light? Sorry.
And not related to the experiment, but I was just confused by this today when I bought these sugar cubes for this experiment. You can see in France we have like a nutritional score, and it got D, but the score goes all the way down to E. And I'm just wondering how they rate it, where like pure sugar isn't the lowest on the scale. It still goes lower. Like, are they looking for a combination of fat and sugar to get it from D to E? Or like, that didn't make sense to me, that pure sugar doesn't get the lowest rating on a nutritional scale.
Yeah. Of course, if I was doing this in a classroom, I would springboard into why we would have iron in our diet, and then talk about red blood cells, hemoglobin, and other foods. So, yeah. So.
That's excellent. Thanks, Paul. It was a high note to end things on. Does anyone have any final thoughts, either for Paul for those last experiments or for anything we've seen today before we all say goodbye and close the session? Doesn't look like anyone has anything more to say. So I want to thank everyone again for joining and for being up to the challenge of sharing experiments without speaking. Also, everyone who joined to see some of the experiments, some new faces this time as well, even though it's not a huge crowd. So it's always great to see more people come out. And this is always, for me, a big highlight of the month, having people along for this. And it's one of the things I get the most enjoyment and satisfaction from doing. So thank you all again, everyone, and have a great evening.
Thank you. Bye.